I'm sorry. I'm sorry. I'm sorry. That was really kind of important. I had to take that call. I apologize. Okay. So it goes on to talk about wells, which we're not going to do anything really about on page 41. All right. Let's look on page 42 on the bottom. It's talking about water heaters. Now, we take the water heater for granted every day, right? Excuse me. We washing dishes, we turn on the hot and it comes. We're washing our face, turn on the hot water, here it comes. We're getting the shower, we turn on the hot water, here it comes. Nobody thinks about the water heater until it's never a problem until it's a problem, right? But let's look at the basic mechanics of a typical water heater that's gas, because we use a lot of gas water heaters here in the city and surrounding areas. So if you look at the anatomy here, on the left-hand side, we have that black galvanized piping coming down, just like we do on the hot air heating system. So that's the source of the energy coming in as before. So there's a shut-off valve. Then it makes that 90-degree turn, as it does in the hot air system. And you'll note there is this extension pipe. Who can tell me or remind me what that extension pipe's purpose is? It's the same purpose as it was on the hot air system. I know some of you people were on that. Moisture. Very good. So the reason is if there's any moisture in the gas line coming in, that will be heavier than the air of the gas itself. And so therefore, the moisture will drop into that little leg, we'll call it, and the gas free of moisture will enter into the system. Okay. So now when you look at the interior part of this large cylinder, which is your water heater, you'll note on the bottom it says burner. This is how and when the water is going to be heated for on-demand use. Now, when this water heater, it's a tank, gets below a certain level because it's been on demand. So where we use a lot of water would be in a shower. If we were washing in hot water, a lot of water goes through the washing machine, right? So when it passes a particular level, you'll hear the woof, right? When you walk by, you woof. And that is when the burner is igniting, because the intake valve, which you see on the right-hand side, is now going to bring water in to refill the tank because it's gotten below a particular level, and we're going to reheat more water for demand. We hear the woof of the gas turn on and the burner igniting to heat the water. Okay, a couple things to remember. On the top here, we'll see three different forms of some kind of piping. One is the hot water out. So when water is demanded in hot water, it now leaves the tank and comes up here on the left-hand side and follows the whole plumbing track it needs to go. Up through the floor of the first floor, up to the second floor for the shower, for instance. And on the right-hand side is how the cold water comes into the tank to constantly refill it so it can be reheated. On the top, you will note this larger vented, bent piping. Does anybody know what that is? Now, if you remember, it looks just like the one that we saw in our hot air system. What is that vented pipe coming up? Come on, guys. Somebody alive out there? Okay. That vented piping is for the carbon monoxide. Ah, yeah, it's gas. That combustible creates carbon monoxide. So that large bent piping is going to the chimney to remove and release and expel the carbon monoxide coming from the breakdown of the gas creating this source of energy. On the right-hand side, you'll see the temperature pressure relief valve. This is huge. The temperature pressure relief valve is really important. On many water heaters, the temperature pressure relief valve is on the outside of the tank. It could be, depending on manufacturer, on the top of the tank. It's made of brass, and it has threading on the inside of this brass fixture. That inside threading is called a female threading. It's designed to have a pipe or of some material or PVC with the threading on the outside of the pipe, known as a male fitting, hook onto this, either on to hang vertically or to come across the top and then have an elbow, 90 degree, to go down to the floor. The purpose of that is this. If an individual was to walk by a water heater, the temperature pressure relief valve is there if the thermostat on the water heater should become defective. State Farm Insurance Company did a commercial years ago where you would be, the camera was like across the street and you're looking at a cute little Cape Cod or something. All of a sudden you see a water heater penetrate through the roof of the Cape Cod and take off. And you're like, yeah, sure. No, that's for real. The pressure can build up in a water heater to explode like a rocket over 2 stories in the air. That is truism. The purpose of the temperature pressure relief, see, pressure relief valve is if the thermostat is deficient and the thermostat keeps allowing the water to cook, for a better choice of words, the heating system doesn't shut down and it keeps boiling the water and the pressure within the tank becomes so great, the purpose of the relief valve is to shoot out the hot water to relieve pressure so it doesn't, like a rocket, take off 2 stories in the air. If an individual would happen to walk by at the exact time that temperature pressure relief valve should release, for the average human, it's going to hit them in the chest, the neck, depending on your height, right? Somewhere in the thoracic area. If it's a child, though, and they're much shorter than us, yeah? So it's very possible it's going to hit them directly in the face. It's horrible. It's scalding water. The temperature pressure relief valve extension pipe that is mandated on particular types of mortgages is there for a safety purpose. The extension pipe should be to within 6 inches of the floor. So regardless of whoever is walking by, if that water heater was to ignite and explode and release that hot boiling water, it would release it, it would go down the extension pipe, and only someone's feet could be damaged, or ankles and legs. If it's an FHA VA transaction, it's going to be mandated that the extension pipe be added. On a conventional, it needs to be added and will show up on a inspection report as a safety, and it really should be. So those of you who are getting listings, you need to walk through the house, obviously. And if the water heater does not have an extension pipe on the temperature pressure relief valve, please encourage your sellers to have that added. It is very inexpensive. It does not have to be copper. It can be PVC, right? So the threading is female. And if it's on the side, you just need a vertical pipe like 5 feet long in PVC just to screw it in. It's like a $5 piece, not expensive. You can get it at Lowe's, Home Depot, and the homeowner can screw that in, right? Okay. So it's important to understand the purpose of what a water heater does and how it really could be a dangerous piece of equipment. Taught this class years ago, and a young lady went back to her apartment and looked at her water heater, of which on the temperature pressure relief valve, the landlord had put a brass lock on it, had threaded it closed with a lock so that it would never discharge and it would only then explode. The young lady now knew enough to know, reached out to her landlord immediately about the dangers of this, and that was changed. Why it was done, I would have no idea, but it can be very dangerous and explode and be a rocket to go 2 stories in the air. Absolutely can happen, without a doubt. So, all right, moving on page 43, you'll see the temperatures, where the water heater is set, and what time it would take for serious burns. So at 120 degrees, it's going to take more than 5 minutes. With 10-degree differential, it goes from 5 minutes to 30 seconds. 140 degrees is 5 seconds. 150 is 1.5. So these are good little guidelines for households who have small children. It is something that really has to be taken in consideration. Individuals that it's an adult-only property may want higher temperatures on their water heater for cleaning purposes, such as the washing machine, such as the dishwasher, okay? But you have to be cautious. Below that, you'll note an electric water heater. Now, the concepts are all very much the same in that water has to come into the system, water will leave the system. The electric feed comes from the top rather than the piping on the side when we showed the gas one. And the heating element is very high in the tank rather than the heating element, which is the burner, is low, located low on the tank for the gas system. So there's some difference in configuration, but the concept is all the same. It still has a temperature pressure relief valve, right? Because that's your safety, and all that is the same, okay? Again, on page 44, it goes into more detail about the temperature pressure relief valve, but I think we've touched on that pretty good. It also gives an illustration of an oil-fired system. Now, the oil-fired system, again, has a relative similar anatomy as both the electric and the gas, but its source of energy is that of oil rather than gas or electric. Rarely do you see these. This is a rare occasion. If a property does not have gas to the home, almost always what you will find is an electric water heater rather than an oil water heater system. When you look on page 45, it gives an illustration of how does this water heater work if I was to slice a house. So if we slice the house on the first illustration with a basement, you will see the water heater and how the piping seems to maneuver its way like a spider web. But clearly, it comes in through to the property, and it indicates where the meter valves are before and after the meter, reaches up to the ceiling and then goes across, then will enter into the water heater itself as the supply, right? Because we have to be able to fill the heater. It shows how it exits from the top on demand. As the water exits, it now has to then go to the source where it needs. So you'll see hot to the home, there's a vertical pipe going through the ceiling and then the flooring of the second floor, ceiling of the basement, flooring of the second floor, up to the vanity, because the vanity has a hot and cold shutoff. You'll note, though, that hot release pipe doesn't go to the toilet. What goes to the toilet is the water line of the cold water running through the house. If your toilet is warm when you sit on it, and I've actually seen this happen, where the wrong pipe was attached. It's hot water going in the toilet, which is lovely in the wintertime, but not practical and very costly. It always should be cold water. So that was installed improperly. So who might have done that? What individual might have hooked up a hot water to the toilet rather than a cold water? Unlicensed, yep, Uncle Joe, right? Uncle Joe, great guy, but he goofed. It's cold water goes to a toilet, right? A plumber would never do that, okay? When we go on to page 46, it shows how the illustration and how water comes in and goes out and passes through on a slab foundation. Basically, the mechanics is all the same of how these work. There's deviations on circumstances, slab, basement, electric, gas, oil, okay? But the basics are always the same. I want you to look at metal distribution piping. And the first you will note here talks about lead in the 1900s. So remember when I talked to you about lead intake pipes, if the property is 90 years old or greater, that you always want to check off the inspection of water, because you just never know if the intake pipe is of lead and how you're going to address that. Galvanized steel then came in the 20s, and that's going to be a heavy black pipe that allows distribution of water or gas to come in. And then in the 50s, there was copper. Now, copper is still very popular and copper is still around, though copper is the most costly of all the piping that is available to enter into a home. We also then look at what is called rigid plastic piping, known as PVC, right? And that's that white piping. You see that a lot on the sewer lines going out and running through a home. And then the most modern would be PEX on the bottom right. This is a flexible type of piping. It's like a hose. And what you'll note when you see this is there is a center column that has on and off switches. To me, it looks like a spinal cord. That's how I think of it. The blue side is all the cold water and where it's releasing. So those little switches are your shutoff valves, where the blue is taking off throughout the home. The valves on the red side, which is the hot water side, would shut off too. So you have blue and red, hot and cold. And it's kind of like a spinal cord. It's like a main plumbing area, you will see, in new construction and rehabs. Talks about different types of valves on page 47. Ball valves, gate valves, saddle valves, globe valves, hose bib. Hose bib is really important. And there is a whole thing about hose bibs. Oh, it's on 51, so we'll pick that up once we get to 51. Also talks about water softeners. And you'll see it talks about a 2-tank system. You will see this in the burbs where there is well water. We don't deal with it a lot, even the burbs. Most of it has public water, but on occasion you're going to run into well water, and in which case you will have softeners. So we're not going to spend a lot of time, but they have a really good illustration on page 48 at the top, how the softener is installed, how it affects the water throughout the house and the system. Just something to review and understand. We're going to talk about garbage disposals. Now, I'm sure most of you are very familiar with the garbage disposal. It's a lovely tool until something goes wrong. Then it's not so lovely. Garbage disposals come in various strengths, known as horsepower. The smallest is a quarter. The largest for most residential is what's considered a full horsepower. Now, in most new construction or rehab, they go from 1/3 of a horse to 1/2 of a horse. is generally how the GC puts them in. I will tell you this. If you have to have a garbage disposal installed and replaced, do yourself a world of favor. Spend the extra $50, $75. The cost doesn't change installing the horsepower, right? So the labor's all the same. Spend a little extra money, especially if you are replacing this in a home that has renters in it. God only knows what they put down a garbage disposal to break it.
Wax.
Wax is a big thing. Nuts and bolts. Shrimp shells. I learned my own lesson. You never put a shrimp shell down the garbage disposal. All these horrible things. Even if it's for yours at home, put 3/4 to a full horse in. Now, with that said, you'll look on the illustration and it shows you a reset button. If this gets clogged, you go to flip it on, and you always run cold water with this. You flip it on and you hear, instead of, you're like, damn it, something's stuck. So there is like an Allen wrench, which is a 90-degree turn, one to the left side, then comes down vertically, and then a 90-degree to the right side, that you would insert right up the bottom of your garbage disposal. Fits like a key, like a little key goes in there. And you will easily move it back and forth, trying to release whatever's jammed itself under the blades. And many times you can actually feel it loosen. And then you can have a full range of the blades will move nicely. There's also a reset button under there that you're going to have to hit, and then you run the water and turn it on. Okay? It's never recommended to put your hand down there, obviously. But you do what you got to do when no one's around, right? Okay. Hose bibs on page 51. Now, this is really important. This is a really good reason to reach out to your clients in October. October is a really good month to reach out to your clients and say, I'm reminding you to shut off and drain your hose bib. Okay, so what's all that mean? The hose bib is the connection on the outside of your house where you hook the hose to water the lawn, to water your garden, to wash your car, right? In October, you go in the basement and you look about where the hose comes into the house, and you'll see that water line across the ceiling of the basement. And then you'll see a shutoff valve. You shut that off. You go back outside, and now you turn the valve on the outside. What have you done? What you have done is prevented, by shutting off the water line on the inside, any water to flow through the wall to the outside of the house. By going on the outside of the house and opening the valve, you are now removing the water from the interior valve that you shut off through the pipe going through the wall to the outside. You have drained the line. There is now no water in that line through the wall to the outside of the house. Therefore, that part of the pipe can never freeze. And that's what happens. You get calls in March and April. Oh no, there's water pouring out the side of my house from the pipe where the hose bib is. They didn't drain it, right? Now they're calling you for for a plumber. So in October, it's a wonderful time to reach out to your clients, A, to keep in touch with them, and B, for something of value. And it's very valuable to remind them that they have to drain that line to prevent the next costly event of having the pipes replaced by a plumber. Okay, makes sense to you guys? All right, moving on. Let's look on page 52. 52 talks about a water hammer arrestor. How many of you either grew up in a house with hot water heat, such as radiator baseboard, or had a grandparent or an aunt or somebody's home that you used to visit and you would hear banging in the wall. Any of you experienced that? Hello? No? Okay. So what happens is air gets caught in the line, the water line sometimes, and it causes banging sounds in the walls. They have this air chamber release that can be added to the system that doesn't let water out, but it does allow air to escape to prevent that banging sound in the wall. All right, on page 53, we're going to talk about waste and vents. When you look at a home that is not a flat roof, so it's an A roof, and you'll see pipes, you know, so big coming out of the roof as you're driving by, you see pipes. These are air vents that allow waste to be pushed out when you flush the toilet or water goes down your drain. This allows air up through the roof to allow the water to push down. Air plays a big part in plumbing. It's a force used to move water. On air emittance valve, what's really important, what I want to talk about here, is what you'll see where the sink is. On page 53, there are two sinks. You see a straight line pipe coming down, and then you see the U-trap, and that's what that's called. It looks like the letter U. It's the U-trap. The purpose of the U-trap is to hold water. When you shut the water off at the sink, it stops going down the vertical pipe, and it gets caught in this U-trap. The purpose of the U-trap is to prevent gas of sewer gases backing up into the property. The sewer gases will be in that pipe beyond the U-trap, but we don't smell them because the water prevents the gases from coming up through the sink trap, right? So they have a big purpose. You are showing property. And another good illustration is on page 54 of this. And this property's been vacant a long time. Maybe you're working with developers or investors, or it's just, you know, grandmom had to go in a nursing home, God forbid, and so no one's been in the house a while. And you go in and you go, ooh, smells funny. Couple things to keep in mind. When it doesn't smell right, it smells like sewage, it could be one of a few reasons. One is that the water in the U-trap that was to prevent the sewer gases from coming up into the home has evaporated. The home has been unused, and so water does evaporate. So it's now an open passageway to allow the gases to come through. That could be the source of the smell, or in the basement, you have a cracked sewer line. So these are things you want to look at and take into consideration why it smells funny when you walk into one of these properties. There's also cleanouts. These cleanouts are used by the plumber. When your sewer line is running slow, your toilet is draining slow, the water coming out of the kitchen sink and draining into the sewer line is slow, there could be some form of a clog. Is it grease? Is it food particles? Is it improper things going through your toilet that shouldn't be, like toys, little cups? People with children, it's amazing the things that end up going down the toilet and the little kids waving at it. Yeah. So that's when the plumber has to come with a snake and they run through the sewer line to see what's going on there, right? Let's talk about on page 55 septic systems. Now, on the illustration on the top left, talks about storm sewage and sanitary sewage, which we consider dirty water sewage, right? from your toilets, from your sinks, from your washing machine. Okay. Storm sewage is how the downspout will come down, and you'll see it goes into some sort of a piping sometimes. That goes underground where storm water is trapped. Is a very separate entity from sanitational water, which is what we consider brown water, dirty water, caca water, right? They're separate, two separate things. But when you look at the top here on page 55, we talk about septic systems. Now, the septic system works as this. You see the illustration of the toilet on the first floor. We flush the toilet. There is a stack pipe that's allowing air to help push the product down and out of the foundation into the septic tank. That's where the wastewater sits. Over time, the solids sink to the bottom. On the top is the dirty brown water. Over time, that fills up the tank due to the fact that more solids have taken up room in the tank at the very bottom. Now we have to have an overflow system. So when that happens and the water line is much higher in the tank, it overflows out to that piping to the left where it says fields. These are known as leaching fields. The brown water will then continue on away from the septic tank and expel itself in these pipes that are usually PVC with these little holes. And the brown water goes out further out away from the sewer line to eliminate the pressure on the tank until the tank has to be drained and cleaned, right? That's when sanitary companies come out and they actually suck out the sludge at the bottom, which are the solids. That's called leaching fields. And that's where the grass grows the best out there. That is not where you're going to put your garden, for sure, right? But this just gives you some general perspective of how septic tanks work. And if you are accidentally in the suburbs and you're selling property, note, a defective septic system can run anywhere from $5,000 to $35,000 in repairs and upgrades. So don't have a buyer come to you and go, nah, I don't need to worry about that. You need to worry about that. You must pay to have that inspected. It goes on page 56 to talk about sand mounds. Anyone here who has ever known of someone who has a home out in the Poconos, up in the Poconos area or much more urban areas, they do this sand mound. Instead of the leaching fields where the overflow of the brown water is, in this illustration that you see on the left of page 56, it's where the brown water would then pass along into a pump. The pumping system then takes the brown water and goes up on a mound. That mound is full of sand. And it pumps the brown water up to the top of the mound that the sand will act as a filtering system as the water through gravity is absorbed through the gravel and sand into the soil. So if there's a home in the Poconos that has well water, clearly these two are not near each other, right? We can't have the sand mound anywhere near where our well water is, because then the possible contamination of water from the sand mound would enter into our well water. So the well's in the front of the house and the sand mound is in the back of the house. Make sense? Right? Okay. Look at page 57 on the bottom. This is a really good illustration on the shape and the style of a gas meter. Gas meters in Philadelphia are in the basement most of the time. Occasionally, you'll find them on the front of the property because the front of the property is where the street is. And the street in the middle is where the gas lines are, right? So when you're doing your pre-settlement walkthrough and you have to get your gas and water meter readings, you'll note that that's going to be on the inside wall most of the time, in the basement on the front wall. And that's what this meter looks like. It's the shape very much to that. And there is numerical dials on the front, and that's where you'll either write the number down or you'll take your phone and take a picture of the gas meter numbers. It goes on to talk about on page 58 the shutoff valves for gas shutoff into the home. And it also gives you a little bit of an illustration of the gas shutoff if the home has propane gas. Propane gas, as they're showing on the illustration here, as a tank visual above the ground. There are propane tanks that are placed underground in some locations. On page 59, it's a real good understanding of fuel tanks in a basement. We're talking about oil tanks. Now, let's talk about something here. Oil is still very viable and is used a lot in the burbs and still in the city of Philadelphia. North Philadelphia, West Philadelphia, you will still find a lot of homes heated with oil heat. I'm going to give you some tidbits here. Those pipes that you see on the illustration, one's a fill pipe and one's a vent pipe. They are customarily, but not always, found in the front of the property. You are showing property. You get there before your buyer does. And it's really important to look at the outside of a home. I like to take my buyers across the street and teach them to look at the house. What do we see? Do we see gross defects? We look at the pointing, we look at bulging in the masonry, either brick or stone. Like, let's get an overview here. So you're looking at the property and you note these two pipes at the front of the basement. You say to yourself. You look at your bright form, the MLS listing, and you look to see if the property is oil or gas. And you happen to notice that the MLS says it's gas. And you're like, let me look inside. So your buyer comes and you're in the basement. Now you're being Sherlock Holmes. You saw two pipes on the outside of the house. You get down there and you look at the heating system, and it's a gas, air, hot air system. Two things you have to note. A, is the oil tank still down there? B, is the oil tank gone? If the oil tank has been removed, and this is a property your client is interested in, it is extremely important on your home inspection to have that home inspector investigate and inspect those two pipes on the outside of the house. Where those pipes for the intake comes in, was that abandoned? Was it filled with concrete or some sort of a substance that would prevent an oil guy from putting his connection into that and add oil? Here's why. If that is not abandoned properly, I know factually of people who have had 500 gallons of oil dumped in their basement. I'm going to give you a little scenario. It's wintertime. The guy who delivers the oil is on the phone. He's arguing with his wife. He's arguing with his kid. He's arguing with the girlfriend, God knows what. He's got the hose he's dragging up the front lawn, jamming it into the fill pipe, turning it on, paying no attention what the hell's going on. 500 gallons just dumped on the floor of somebody's home because the oil tank had been removed. It was converted to gas, yet the fill was not abandoned. He was at 123 Pine Street. He was supposed to be on 123 Maple. This is a big problem. That fill has to be abandoned properly, so he couldn't shove that in there. If he couldn't get the fill in there, he would have stopped and thought for a minute, why isn't this working? Hung up the phone and realized he was at the wrong address. Okay, so very important to make sure all the mechanicals are working correctly, and if not, have they been abandoned correctly to prevent those huge accidents. Okay. We go on to chapter 6 that talks about general home systems. So we're going to talk about foundations, foundational wall. It shows on the bottom left concrete block construction or poured concrete construction. So when the home was built, the foundation was dug out, and it was determined the type of foundational material that was going to be used. If it's going to be poured concrete, there is a form that is built, and then the truck comes with the wet concrete, and it pours the wet concrete in between these forms, of which, when it dries and cures, the forms are removed, and there's this wall of concrete that's going to be the supporting factor for the home. Or is it going to be block construction, where masonry men are there laying cinder block and then putting concrete, laying cinder block, pouring concrete, laying cinder block, right? The mortar in between. So that's the difference between the two. And then it shows if it is a crawl space or a slab construction, how the foundational component would look. It also shows pilings on 661 on the bottom. So piling foundation is when these huge holes are dug and steel pillars or huge cured wood pillars are then inserted into the ground as the foundational holding. Where might you find that type of foundation? Because it says here, used in poor soil conditions. Where locally might we find poor soil conditions? Hello? Okay. So that would be at the shore, right? Because we have sandy soil. And that's where you will find the foundations to be that of pilings, where the home is raised and sits on pilings that were pounded into the soil as the foundational. Let's talk about sump pumps on 62. Now, if you show a home and it has a sump pump, that's actually a good thing. It's not a bad thing. What that's telling you is that there is a high water table in the immediate area. I'm sorry, I have to take this call. Hello? Sorry, guys. All right, so let's talk about sump pumps. Sump pumps are fabulous. When they're in the home, it's not a bad thing. That means that the home is at a high water table level. Philadelphia, Bucks County has high water tables. Keep in mind, parts of Philadelphia really do too, because we're sandwiched between two rivers. So depending on where the property is located, or are you near a lot of creeks? So anyone near Fairmount Park is probably going to have a high water table. The water level in their soil is high. When you're digging down, you're going to hit water. When you're at a high water table, you don't have to dig as far. Boop, we hit water, right? So having a sump pump means someone else has paid to have this corrected. Now, the purpose of a sump pump is to alleviate the water pressure under the home. There is something what is called hydrostatic water pressure, and that is when the water table is so high under the foundation of where this home is built that when there is an excessive amount of water in the soil, it can literally the water can force itself up through the concrete, and you actually can get puddling in your basement floor. And I speak of experience. I live very close to Fairmount Park, blocks away, and I have a very high water table. I suffered from a lot of wet basement situation due to the fact of the quality of the bricks coming into my home were very poor. And rain would push itself through the brick and come down the walls on the inside of my basement and then hit the floor and go across. So long story short, can't take it anymore. I have a waterproofing company come in. And water will find its own way. Water always wins. Sort of a blanket statement. The idea of a waterproofing company is to guide and control the water. So along the perimeter of my house, I live in a twin. So on the side, obviously not connected to my neighbor, they jackhammered the whole foundation and put corrugated kind of plastic against the foundational wall. And there's a trough that's probably 6 to 8 inches wide, of which when the water comes down the wall, it falls behind this corrugated plastic, lands in a trough, a deep ditch that is filled with stone, and it's pitched to go to the sump pump. And then when the sump pump fills up, the sump pump discharges that water into my utility sink. In Philadelphia County, it is allowed for the sump pump to discharge in the utility sink. In the suburbs, that is illegal. The sump pump has to discharge away from the home, but on the same parcel. So you'll see in a backyard of a property that has a sump pump, this long 20-foot PVC piping, because that is how the water is then discharged away from the house. Once the sump pump in the basement kicks off, that motor sends that water down the PVC pipe away from the house, right? Okay. So having a sump pump's not a bad thing if someone else has spent the money. You'll note about proper grading on the bottom of page 62. Many, many times, water penetration into a basement, a high percentage of that is caused by improper grading of the soil around the foundation. The soil next to the foundation has to be higher so that gravity allows the rainwater to wash away from the house, if the house is here. It should be 1 inch per foot. So what does that mean? That means 6 feet away from the house should be 6 inches lower than the level of the house. So for every foot we go down, we pitch it by 1 inch. 6 feet away from the house should be a differential of grading away from the house of 6 inches. If the owner of the house takes care of the grading and changes it and corrects it, will be a huge asset to the ability of water to penetrate into the basement area. It may or may not solve all of the problem, but it's going to be a huge asset to assist the water running off and away from the home, okay? Checking your gutters and downspouts, huge. Have a downspout that comes from the roof, boop, there's one little 90-degree angle and all the water runs right there. Well, that's 8 inches away from the foundation. Where the heck do you think that water is going? If all the water is coming off the roof, hits that 90-degree turn at the ground level, and is spewing out all this water 8 inches from the foundation, boop, it's going right down there in the foundation. We need to extend that. We need a longer pipe to go away from the foundation. So as the water comes down the downspout, makes that 90-degree turn, it's then pushing itself 10 feet away from the house to be discharged into the lawn over there, not 8 inches next to the house, okay? A lot of common sense things to take into consideration. We're going to talk about construction. Look on page 64, general construction knowledge. It's going to talk about different forms of construction known as balloon frame construction and that of platform construction. This is not something you need to know a lot about. Just educate yourself a little bit about this. Notice where it says floor joists on the bottom of page 61. Now that, I will tell you, is something you will see and need to understand in a home inspection report. Floor joists run 2x8s. It means 2 inches thick by 8 feet long, or 10 feet long, 12 feet long, or 14 foot long. A good home inspector, you will find them measuring the width across in a row home. Is it 12 feet wide, the row home? Is it 14 feet wide? How long is the span of the joist? He will also measure the height of the joist. How tall is that joist? How thick is that joist? That makes a difference. This is all physics. The greater the expansion from side to side of the property, the greater the joist size needs to be, both in height and in thickness, to be able to support everything above it, which is your first floor, and then your second floor, and maybe your third floor, okay? All of that is based on the foundational sizing. So that's really important. It shows you what truss construction looks like if you see that in a home inspection report. And it also touches on what is a load-bearing wall. You'll be showing a house and the potential buyer will walk in and say, wow, this house is great. If I could only take this one wall out. Hey, Vic, can I take that wall out? Well, we're not engineers, architects, home inspectors, right? So we can't answer that question factually. And that's where you would strongly suggest hiring someone who can answer that question. And yes, non-weight-bearing walls can be removed, and weight-bearing walls can be removed interiorly, but have to be supported in another fashion to then hold up what's above it, the second and third floor. Money can fix all of this. The question is, does the buyer want to spend that kind of money to make those alterations to their liking? Okay? Never answer, I think You can move that wall. Don't do it. All right. Talks about different types of subflooring. That's the flooring that we see placed up right above the joist, and the type of lumber that could possibly be used for that. Talks about different types of beams, laminated, solid wood timber, something that's called an I-beam, which is metal construction. Let's look on page 66. Typical 2x4 wall framing. Now, it's showing here a window and a door on the top left of page 66. I heard a commercial recently and I thought, wow, that's really true. It was a window replacement company. And they talked about that windows and doors are nothing more than holes in our walls, in our homes. They're holes. And I thought, wow, that's really true. A window and a door is a hole in the construction of the building. And so how do we insulate these holes from the hot and cold? Obviously was the whole idea for that of this commercial about replacement windows, but we need to talk about the holes. You'll notice at the top of the window and the top of the door, there is a piece of wood, solid piece of wood that goes all the way across. That is known as a header. A header is a support to support everything that is above the hole, because now the hole's there not supporting what's below it and above it. We need to support things above it, and the header goes all the way across, which is a support beam to hold up where the hole has removed the support. Does that make sense? So in construction, you'll see the headers above doors and above windows are supports. So you can't have a hole without the header because you'll have nothing to support where that hole is below it. All right. Well, look here at the illustration on page 67 about a brick home elevation, and it shows the exterior of a brick home. So we have a lot of that in Philadelphia, right? We have a lot of masonry homes. And where the window is, so that's our hole in the home, it's not wood. It's made of metal, and that is known as a lintel. The lintel is put above the window to support where that window hole is. And you'll note that the metal goes beyond the opening of the hole. It's going beyond that to support the bricks where the hole has now been taken up by a window. So the lintel goes wider than the hole in the window to support what's above it. It's the same concept of a header, but it's done with metal. Huge metal pieces of metal go above the window. Stucco, traditional cement 3-coated. Now, stucco is a huge problem. The old stucco done 50 years ago, not such a problem. The construction of stucco starting 25 years ago or so has been a huge problem. Any one of you who do new construction will note in the last few years, stucco construction has really taken a back seat. The litigation and lawsuits from stucco construction are huge and extremely costly. Improper stucco construction has caused enormous problems with water penetration, getting behind the stucco, sitting there, not ventilated, causing moisture buildup and mold. Huge, huge, huge problem. If you have a buyer who is interested in purchasing a property with stucco construction, you must hire a stucco specialist. The home inspector is not your guy. You need to hire a stucco specialist to come out within the time frame indicated in the report and do a thorough inspection of the stucco. It is an invasive procedure, meaning they will actually drill holes around windows and doors, which again are the holes of the home where water penetration can happen. They will drill very tiny little holes, and then in those holes, they will put a moisture meter and read to see if there is moisture in those areas. If there is, that's going to be a big discussion in your reply to home inspection report. Huge. Okay? So please make sure that your buyers are doing this. If you have a buyer who refuses to do an independent stucco inspection on an email, so you have a paper trail, you must inform the buyer again in writing that you are strongly suggesting that they do a stucco inspection by an independent stucco inspector, so that when this becomes a problem a year from now, you have paperwork to cover your bottom that you advised your buyer to have this done and they chose not to do it. Let's talk about double hung windows. Now, this is the second time we're going to talk about it because we talked about it earlier in the class yesterday regarding what? Does anyone remember when we talked about double hung windows last week? Lead-based paint. Very good. Thank you. So double hung windows, again, is the friction of the window. So the window can raise from the bottom up, or the window can come from the top down. Where the frames rub up against each other is where the friction happens if it's a wood window and there is lead in the paint that is causing the friction. Lead is heavier than the dust, and the lead dust then falls to the ground. And that's where ingestion can happen. We turn to page 70 and we talk about garage door openers. So remember, there's an I-beam that is running from left to right. On the frame of the garage, boop, is a beam. Now, if something passes that beam when the garage door is going down, it is supposed to stop the garage door from moving any further. It whoop, stops it. In a home inspection, you'll see a home inspector hit the garage door, bring it up, and then hit it to come down, and he'll throw his foot under it to break the beam of light to make sure that the garage door stops and is functioning properly, right? This is for pets, children, etc. Let's talk about insulation and ventilation on page 72. A house has to breathe. I've talked about this before. A home is a living creature. It has to breathe. And in the breathing process, or the lack thereof, is when we run into problems. These problems happen in crawl spaces and in attics. Heat rises. And so once it gets up to the second floor and then penetrates through the crawl space and access to the attic, it has to go somewhere. If it doesn't go somewhere, the attic will build up moisture. A good way for attics to breathe is where it shows on page 73, and we're talking about an A-frame roof here. It is called a roof vent. This is where the hot air comes to the very peak of the roof, and there is venting all along that, and it allows it to escape. It allows moisture to escape. When a home inspector is in an attic and or is poking their head through a crawl space, they are looking at the nails that are coming through the ceiling of the attic, which is your roof, and they're looking to see if there's any black rings around that nail coming through. The black rings are showing a high moisture level, which is telling the home inspector that the roof, the attic, is not breathing properly. You can either have a roof vent, which is at the very top of the roof, or where the roof overhangs is vents to allow heat to escape through the overhangs. There are various places on how a roof can ventilate. Really important. You'll see on 74 where it shows a bathroom exhaust through a roof. All bathrooms have to have an exhaust. Now, with that said, when we do so much of reconfiguring of homes because we are doing rehab work, they will put a powder room in the middle of the home on the first floor. It doesn't have an access or an exterior wall. The exhaust fan has to go somewhere. It is ideally to exit outside. In a situation where it can't access itself outside, you'll see in a home inspection report where they'll state it just goes into a crawl space, which is not where it's supposed to go. It is actually to go to the exterior part of the home for moisture ventilation. Talks about on page 75 the different types of roofs. You'll see a gable roof, a hip roof, a shed roof, a mansard roof, different types of roof lines, design of roof, okay? Then it talks about on different roofing terms. So this is something, if you're dealing outside of the city and you're getting a home inspection report, you can relate to when they talk about. There's different roof vents you'll see there. They talk about the gable style of the roof, where the skylight is. What is a valley of a roof? Where two different angles meet on the roof line. The plumbing vents, the eaves, which are the exterior very ends of a roof, come through. They'll explain what a dormer is. It's showing you, again, a roof vent. A step flashing, where the dormer itself, that little window, the dormer meets the roof line. That's known as step flashing. Okay. Different types of roofing materials, such as asphalt shingle roofing. It also talks about wood shake roof, we don't see very often, or wood shingle roof, but it does exist. We're going to talk about tile roofing, sort of that Mexican tile look. Low slope roofing, that's what we talk about. A lot of the flat roof we have in the city of Philadelphia has a very low pitch, not a lot of a pitch. And it talks about how it's done with a rubber roofing material and how it runs up the walls, the side walls, to prevent water penetration. Chimneys. Chimneys are very important in the maintenance of a home. Different types of chimneys, depending on the age of the property, will determine the type of chimney interior you're going to find. Is the interior of the chimney only that of the inside of the brick that we see on the outside, which happened hundreds of years ago? Or is there a sleeve inside of the chimneys inside the bricking we see on the outside? often made of terracotta, which is a brick-like substance. That's that orange flower pot. That's terracotta, right? Or is it stainless steel sleeve that has been inserted? You can often tell the quality of a home inspector on how tenacious they are to determine the quality of the chimney, the interior part of the chimney. If it is terracotta, the question we have is, terracotta gets hot and gets cold and gets hot and gets cold, right? It's a very brittle material. And over time, has the integrity of the terracotta been compromised, causing the terracotta lining to fracture within itself? And is it preventing airflow? The airflow out of the chimney is our carbon monoxide, right? We talked about that. So is it preventing, because it is fractured within itself, the inability to have the carbon monoxide escape, causing a real problem? So the quality of a home inspector is often determined by how he or she has determined the interior of a chimney. And if there is a deficiency, and that has to be replaced with a stainless steel sleeve, which looks very much like, but much larger than the stainless steel exhaust from a dryer. It's often what it looks like. And you'll see how it talks about the capping, the solid masonry capping at the top of a chimney. We need to know what the quality of that is, often deteriorated. And here is where I'm not the fan of the drone, who may or may not determine the quality of the capping around the chimney. If it's allowing moisture to enter into the chimney area, that can freeze in the wintertime, causing expansion and additional damage to the masonry chimney itself, right? Thing to keep in mind. All right, guys, that's going to end it for today. I hope we've been of help. I hope that has guided you. And see all of you later. Take care. Bye.
Thank you.